What's going on, everybody? Happy Wednesday to you. Hope everybody's doing well. Hope everybody staying safe, staying healthy, washing your hands, all that good stuff. So today is actually a pretty tricky lesson, okay? So what we're going to look at is we're going to combine the last two lessons of combinations and permutations. So we got to figure out, does order matter? So permutation, it matters. Combination, it does not matter, okay? So it does not matter. Okay, so combinations, permutations. So real quickly, let's go over the formula. So for permutation, it's n factorial over n minus r factorial, and that's it. Combination is n factorial, and then there's two numbers on bottom. It's r factorial, and then n minus r factorial. So we're going to use both formulas on this assignment. The key is figuring out which one we're going to use, okay? So let's look at number one real quick. Okay, so number one, we got 280 people hanging out and they're going to shake hands with each other. Okay, so here's the kicker with this. Okay, so if they are going to shake hands, according to our textbook, this is a combination. It doesn't matter because I'm shaking hands with everybody. Okay, so big number is 280. And then with the handshake, we're only shaking hands with two people at a time. So it's going to be our little number is 2. So our formula tells us it's 280 factorial on top. And then on bottom, it's my little number. And then the two numbers subtracted. So 280 minus 2. So if I do all that, I should wind up getting 280 factorial over 2 factorial and then 268 factorial. 278. Whoop, let me erase that. Let me start over. So 280 factorial over 2 factorial and then 278 factorial. Okay, so I'm not even going to waste my time with the calculator on this one because I know the numbers are going to be too big. So with that being said, let's figure out the old-fashioned way. So I know that 280 factorial is 280 times 279 times 278 all the way to 1. Well, this 278 is going to go all the way down to 1, 2. And then the 2 factorial is going to be just right there. So with that being said, all of this stuff, sorry. So starting with the 278 and below, it's all going to cancel. So really all I'm left with is the 280 times 279 and then the 2 factorial on bottom. So let's do that. So I have 280 times 279. So that's the top. And then I need to divide by that 2 factorial that's left over. And there's my answer, 39,060. So still just a big number, but the right answer. So 39,060 is my answer for number 1. Okay. Now, number 2, this is where it gets a little crazy. Okay. So when it's a gift problem, like on number 2, they say the order matters. So handshake, it does not matter. So it's a combination. But over here, the gifts matter. I guess you care about you getting the first gift instead of the last gift. I don't know. But so in this case, the permutation works on number 2. Okay, so my big number here is 30 permutations, and just like the handshake, my little number is 2. Okay, so I really hope you guys are listening to this because if you get a handshake question, it's a combination. If you get a gift question or a Valentine's Day card question, it's going to be a permutation. So just really make sure that you pay attention when you get those problems. So 30 factorial, and then this one is just on the bottom, 30 minus 2. Okay. So I'm using my permutation formula here. So it's going to be 30 factorial on top divided by 28 factorial on bottom. So I think our calculator can handle this one. So I'm going to do 30 factorial divided by 28 factorial. My answer is just going to be 870. So easy peasy. Okay. So just make sure you guys pay attention to which question it is and whether or not you got to use permutation or combination. Okay, so just real quickly, I'm not going to solve all of these, but I just want to go through these and just go over whether it would be a combination or permutation. So let's look at number 3. I got 115 students who want to be president and vice president. Okay, so if I'm running, I want to be president. I don't really want to be vice president. So the order matters here. So this one would be a permutation. So this one would be 115 permutations of 2. So 115 factorial, and then 115 minus 2 factorial. So I would just do this, and then whatever that would be my answer, okay? All right, so let's go down the left side. So number 5, 16 players being a captain and a co-captain, okay? So they think that these are 2 different jobs. So the captain is better than being co-captain. So this one is permutation. You get 10 applicants on number 7 for 3 different jobs, a computer programmer, software tester, and a manager. So those are 3 different jobs. So it's a permutation. Okay. Whereas on number 9, I got 90 students looking for to be 3 representatives. Well, all 3 representatives are the same, so that one's a combination. Number 4, picking a vacation. One of them is a week long, the other one is only 2 days, the other one's 2 weeks. Well, heck yeah, the order matters. So that makes this one a permutation. Number 6, Chelsea has homework. Okay. Where I think the homework matters, anytime you have a homework question, anytime you're doing a homework question, it is a combination. Okay. I guess they say it doesn't matter if you're the first or the 4th class, as long as you're doing your algebra homework, you're getting it done. Okay. So that means the order doesn't necessarily matter. So it's a combination. Okay. Number 8, you got to read this one carefully. Selecting which 8 players will be in the batting order on an 11-person team. So I'm only picking the players. I'm not putting them in order. I'm only picking the players. So in that case, it's a combination. Number 10, a group of 30 people riding in an elevator. They go up in groups of 6. I don't care if I'm the first or the 6th person. So it's a combination. So really, guys, the trick to these is taking your time and making sure that you pick whether or not it's a permutation or combination. That's going to be the hard part. You guys just got to take your time. And then don't forget your 2 formulas up here at the top, okay? Permutations n factorial divided by n minus r factorial, and the combination has 2 numbers on bottom. It's n factorial and then r factorial times n minus r factorial, okay? So you're typically going to get smaller numbers for your combination answers and bigger numbers for your permutation. Now, you can technically still get big in both, but typically your combination answers are a little smaller. Just a little heads up on that. Okay, if you guys have any questions, let me know. This just kind of combines the end of last week with the beginning of this week, and I hope you guys have a great Easter. Thanks.